Since our very first match, Clyde has wanted to see the world burn.
Clyde. He is nice, he is wide, he's got those little wedgelets, he can get underneath you and he can hold you in place while that flamethrower goes to work. And let me tell you, at this 3-pound weight class, that flamethrower, it's not taking too long to get through some belts, some wheels, some wiring. You can really do some damage with a flamethrower.
The first few versions of Clyde's flamethrower were pretty simple, and while it looked really impressive, we couldn't actually deal that much damage. Even when we got pins where we wanted them, we couldn't melt belts, damage electronics, or catch wheels on fire.
Like Gabe said, we wanted to be able to burn more, so this prompted the first iteration of our weapon design, which used a Venturi system, similar to like a forge burner, to pull air in through the sides. Let's go into CAD to see how it worked.
So here in SOLIDWORKS we can see the outline of the Venturi system. From the back, this brass tubing routed fuel, shown in red, and then the fuel pulled in air through the sides, shown in gray, and at the front we had our ignition over here that used an arc to ignite the fuel. On our left was where our electronics were stored, and the ignition made the fuel go boom. And go boom it did. This iteration of Clyde overheated more electronics than ever before. We were even able to delaminate small sections of carbon fiber and loosen our opponent's belts much more consistently. But most importantly, it looked fantastic. We lit up the entire box with this version of Clyde, and that's what we hope to continue doing.
While we were able to deal some damage with the Venturi burner flamethrower system, we weren't able to really melt our opponents the way that we wanted to. For the most recent version of Clyde, we implemented 3 major upgrades to make our flamethrower deal more damage. We increased the fuel flow rate, we increased the airflow rate by adding fans, and we better mixed the fuel and the air together before they ignited.
It took a few attempts to get these changes right. Our first attempt used this EDF off Amazon, basically just shooting fuel in front of it, as you can see in this testing video here. Safety first. Make sure you're following all the right safety measures while testing.
This first prototype burner didn't work for a few reasons. We didn't have the fuel air mixing we needed, we didn't have the right nozzle geometry to keep the flame at the front of the burner, and we didn't realize this until later, but we didn't have a high enough fuel flow rate for the air that we were using.
To make two fluids, like air and butane, mix well together, you need to induce turbulence. We did this by moving the EDF fan to the side of the burner rather than the back, and adding static mixers along its length. We ran SOLIDWORKS simulations to make sure that everything was well mixed. Unfortunately, that design took up too much space, so we switched to this new design with 2 small RC car cooling fans instead of a large EDF for airflow. We also tried adding some fancy new nozzle geometry to swirl the butane before adding it to the mixing chamber. Let's see how these changes went.
Okay, ignition. Fuel.
This prototype had a couple issues. We quickly melted the thin plastic fan blades, and the new nozzle geometry limited our fuel flow too much. To fix the fuel flow issue, we returned to our old nozzle made of brass tubing. As for the fans melting, we decided to machine our own aluminum fans. Thanks to a couple of smooth brain moments, this took a lot longer than expected, but the final product was really cool. We ran some basic tests, and then used a wind speed anemometer to measure the velocity of the air, and found the velocity from our fan was about the same as that of an off-the-shelf plastic fan.
With fans that didn't melt, we were able to actually get much better testing done, and we saw that we were getting a pretty close to neutral flame, but we wanted a little more range on our fire, so that led to us tilting the canister. We did this first simply by putting the robot up on bricks to see what the effect would be, and it increased our range significantly. After this, we knew that we had to tilt the canister inside the chassis to get higher fuel flow.
We did this testing 48 hours before the competition, so there wasn't any time to actually make these changes. We trashed the CAD and ended up with only 1 chassis, but we were really optimistic because the fire was burning very hot.
Spinner and an undercutter, and it is being caught! Here, recreational doesn't know where to go. with another lipo fire pretty soon.
Wow,
This would be the
robots fight.
Here we go. Nice shots here from Clyde. The control bot, big control bot, able to capture blindside and blast it with fire.
On the driver of Clyde, the builder of Clyde, is so good. He is hoping to rip off more from Clyde.
And Clyde has lost a side here. Pieces are coming out of
Robots fight.
Oh, they went for the boss rush and right.
Big red panda up against the rail, blasting it with fire. A good, clean 10-second pin.
Now the Howler half of Red Panda and the cameras.
Yeah, these iPhone cameras here that are...
Clyde's game going for the pin.
Wow! Capturing all of the robots! All of them!
Even its own flame. This is Clyde's fight.
Wow, and that robot is fully engaged
And a
with the
tap
flames.
out.
One last